So I am hoping that you found the forces and net forces assessment fairly easy. So we're moving on to topic 5. We're going to study and investigate forces a little bit more and introduce some terms called balanced and unbalanced forces. So you should be on orange, page 18. So now that we know how to determine the net force, what do we do with this information and how does it apply to Newton's first law of motion? So if the net force is equal to 0, there is no change in motion. So if the object is at rest, it's going to stay at rest. And if the object is in motion, it's going to continue staying in motion, and it's not going to change its speed, and it's not going to change its direction. So one thing that is really hard for most students when they start learning this is that they think when the net force is 0, it means that it's not moving, and that is incorrect. And that's something that it's going to take a while for it to kind of settle in and for you to really get, and you're going to have lots of questions and lots of opportunities to continue practicing this. And this is probably the biggest concept that students struggle with here in the beginning of this class. So you're going to hear me repeating this many, many times. So on the other hand, if the net force is not equal to 0, that means there is a change in motion. It means that the direction changed, or the speed changed, or maybe it moved from rest to being in motion. So this is fundamentally what Newton's first law of motion is saying, but we're going to go into more detail and try to improve our understanding from just these two basic bullet points and go a little bit deeper. So first thing we want to understand is what balanced forces are. And you may recognize the picture of the scale here. And so when you put things on a scale like this, if things are equal in mass, the scale will be balanced. And the same thing is true with forces. When you have two forces that are equal in size and acting in opposite directions, they are balanced. So the object stays still or continues to move at the same constant speed in the same direction. So again, this is the same as net forces being equal to 0. So when the net force is equal to 0, the forces are balanced. Remember, this does not guarantee that the object is not moving. So some examples of balanced forces. So this car is sitting at rest. The toddler is sitting at rest on a road, maybe not the safest place for them to be sitting. A cup and saucer is sitting at rest on a table. The horse, it says here, it's moving at constant speed in the same direction. So that means there are balanced forces. And this motorcycle is moving at constant speed and in the same direction. So here again, we have balanced forces. So what we have next is when we have unbalanced forces. So unbalanced forces are when you have forces that are unequal in size and opposite in direction. So anytime they're not balanced, they're unbalanced. And unbalanced forces always cause a change in motion in at least one of these three areas: position, direction, and speed. So these are the three things that unbalanced forces cause the change in motion to be, and you're going to want to memorize those three things. So position, direction, and speed. So some examples, and we kind of see this. We've got a 20 Newton force and a 10 Newton force, and this object might be moving to the left, but it's actually getting unbalanced towards the left-hand side. Here is when you have two horses that are kind of that are tethered together, and horse number 2 is actually stronger, so he can actually pull horse number 1 in his direction. And here, they're not going in a straight line because they're going around a curve. So this is also an unbalanced force. And in here, the student exerting the strongest force will determine the direction of the movement. This is kind of like in the horse picture. So let's identify here. So pause the video for a moment and identify whether these are balanced or unbalanced. So let's take a look at the answers. So number 1 is unbalanced because the skier is going down the mountain, and as you go down a mountain, your speed's going to increase. Number 2, 2 people pulling opposite directions on a rope with the same amount of force. That should be balanced. Number 3, a moon that orbits a planet. Well, it's orbiting, so it's going in a circle, which means it's not a straight line, so it's unbalanced. Number 4, an earthquake releasing energy at the fault line. That would be unbalanced. 5, a book sitting high upon a bookshelf. Be balanced. And number 6, 2 women lifting a box into the back of a truck. Now, it is unbalanced because chances are good they're not lifting it directly in a straight line and they're not lifting it at a constant speed. It doesn't tell you that. And since it doesn't tell you it's in a straight line or at a constant speed, you have no reason to assume that it is. So this one would definitely still be unbalanced. So we're going to work on packet pages 19 and 20. We're going to do some of this together, and then you're going to do the rest on your own. So we're going to start out here with the top part of page 19. So question number 1. So we're going to fill in the blanks here with the review. An object at rest will stay at rest, and an object in motion will stay in motion at a constant velocity unless it's acted upon by an unbalanced force. So again, an object at rest will stay at rest. An object in motion will stay in motion at a constant speed in a straight line unless acted upon by an unbalanced force. So number 1, amount of force required to keep a 6 kilogram object moving with a constant velocity of 2 meters per second is blank newtons. So it's actually letter F. A force is not required to keep an object in motion. If it's already in motion, it can stay in motion without any additional forces applied. Number 2, Renata Oil is having car troubles. She's notorious for the trail of oil drops that she leaves on the streets of Glenview. Observe the following oil traces and indicate whether Renata's car is being acted upon by an unbalanced force and give her reasons for your answer. So here we have to look at the dots here on the road. So here we can start out seeing that the dots are really close together, and then as time goes on, the dots get farther apart, which means that this car started out very slowly and started speeding up. So she changed her speed, which means that we have unbalanced forces, and we can tell this because the spacing of the dots has changed. In letter B, here we look at the spacing of the dots and we can see, oh, they're all very equal. So that means that the speed didn't change. The car's moving in a straight line. So no, we've got balanced forces. So the unbalanced forces, no. So the reason is the car is moving at a constant speed because the spacing between the dots are equal. And in letter C, we have the spacing between the dots is getting smaller and smaller. So this car is slowing down. So there is an unbalanced force. And the reason is because the car is slowing down, the spacing gets smaller and smaller. So here is the answers from the answer key if you need to pause the video and copy those down. So number 3, each one of the dot diagrams in question 2 can be matched to a force diagram below. The force diagrams depict the individual forces acting upon the car by a vector arrow. The arrow direction represents the direction of the force. The arrow length represents the strength of the force. Match the dot diagrams from number 2 to a force diagram, and not every force diagram needs to be matched. So it's pretty apparent when we look back on here that letter B has balanced forces. So if we take a look at these, this one definitely doesn't have balanced forces. This middle one isn't balanced, but the last one here is balanced. So that one looks like it could go with letter B. Then if we look at this one, this guy is in letter A, he is speeding up. So in order to be speeding up, they actually have to have more force going to the right because that's the direction the car is moving. So that means the middle diagram here really corresponds with this car speeding up as it's moving to the right. And so the one that's remaining is the first one, which is letter C. Number 4. If the net force acting upon the object is 0 newtons, then the object must. So circle one answer. It must be moving. Well, it could be moving. B, be accelerating. No, it shouldn't be accelerating if it's balanced forces. C, be at rest. Well, it could be at rest. D, be moving with a constant speed in the same direction. Yeah, that's true. And E, either C or D. So it could be at rest and it could be moving with constant speed in the same direction. So the answer is E. The reason it's not A is because A doesn't qualify that it's at constant speed and in the same direction. Then question number 5. These graphs indicate the motion of Carson buses at various times during his trip to school. Indicate whether Carson's vehicle is being acted upon by an unbalanced force. Give a reason in terms of describing what the car is doing, speeding up, slowing down, or constant velocity. So this first one, he is moving at a velocity and it's constant. It isn't changing with time. So his reason here is constant velocity. And if he's moving at a constant velocity in a straight line, he has balanced forces. So the answer here is no. The next one, the velocity is going from some high number to some lower number. So that means that it's slowing down. So that has unbalanced forces and it is slowing down. And the third one, the velocity is going from 0 to some number bigger than that. So it is speeding up and it's an unbalanced force. So here are the answers again, in case you need to write them. Now I'm going to go ahead and have you finish this page up, 6 through number 9, and the answers will be in the next video.